Hey everyone, this is Professor Chan from Math 1245. Today we are going to be going over section 2.4, which is parallel and perpendicular lines. Okay, so yeah, you're just determining whether the lines are parallel and perpendicular. Let's remember what that means, right? So when I have parallel lines, right, I'm saying two lines that do not cross each other. Okay, so just a quick recap, right? So I have two lines like this, right? They are parallel, right? They look like this. And then when I have two lines that are perpendicular, okay, that means they intersect at what's called a 90-degree angle, right? Or generally an easy way is that it looks like a cross, okay? And it creates a 90-degree angle, okay? Now, in my math lab, before we actually do some problems, sometimes they'll just use some symbols um, indicating that it's parallel or perpendicular. So you may see this on your homework. So don't get thrown off by it. But yeah, if you see just like two lines like this that I'm sketching, right, that's parallel. And then if you see something like this, that implies perpendicular, okay? Kind of like an upside down T, okay? So yeah, just want to make sure so you guys don't get thrown off by that, because they might ask you and they just throw that symbol up, okay, and you're like, okay, that's parallel and that's perpendicular, okay. So what, how would it work if we have something that's parallel? Okay, so let me show you something like number 2. So I'm going to go back, I'm going to graph. So I'm going to graph two of them. So 3x minus 7. And I'm going to hit enter. Now I'm going to type in a second one, which is 3x plus 3. And I'm going to graph. So as you can see, these two are parallel, okay? So here's the thing, okay? How do I know it's parallel? I can tell it's parallel because they are equal distance, right? So even though like sometimes you may graph it and it doesn't intersect at a point, it's still not parallel. So let me give you an example, like number like 1. Okay. So if I graph 2x minus 4 and 3x plus 5, right? And you throw this in your calculator. So here's the thing, right? Even though I don't see them intersect, I definitely know they're not parallel because notice if you're reading from top to bottom, right? Notice your two lines are starting to get closer and closer. Okay, so eventually they're going to intersect, which obviously means they're not parallel, right? Parallel means they never intersect at any given point. Okay, I mean if you want to confirm, right, hit your Windows button and you can like lower your Y min. Just a quick reminder what happened. Yep, and we can see it intersects at that point right there. Okay, we could actually do a little bit smaller. Okay, so it intersects at this point here. If you remember, if you want to go back, go to zoom and then go to 6 to get your regular window, which is 10 by 10. Okay, so we notice that number 1 is not parallel and number 2 is parallel. And in order for it to be parallel, we actually have to have the same slope, okay? So in order for lines to be parallel, the lines, they both have to have the same slope. But different y-intercepts. Okay? I want to make sure we include that because the idea is if you have the same slope and the same y-intercept, you're actually graphing the same line twice, right? If I graph 3x plus 7, but then I have the same slope and same y-intercept, it'll also be 3x plus 7. So obviously they're not parallel because there's going to be drawn on top of each other. Okay? So, definition, in order for it to be parallel, it has to have the same slope but different y-intercept. Okay? Okay. So, how do we know something is perpendicular? Okay? Let me graph number 2 here. Okay. So I'm graphing 3x plus 1, and I'm graphing negative 1/3. Just to be careful, I'm going to put the 1/3 in parentheses. I think it doesn't really matter, but just in case. So I'll graph it here, okay? And this will make a perpendicular, graph. Now, one thing you do have to be a little bit mindful is if you're using your graphing calculator, okay? Your graphing calculator is great, but there are some flaws, okay? And if you notice the two lines, it doesn't actually look completely perpendicular. It doesn't look exactly 90 degrees, okay? And the reason why is if you look at your hash marks, and this is just because our calculator, so if you notice our calculator screen is rectangular, it's not really a square. So this one's naturally wider. My X hash marks are a little bit wider than my Y, so if you notice. So because of that, it does kind of skew your lines a bit, okay? So unfortunately, it's not the best visual, but if you're using MyMathLab, you can tell if they're perpendicular because the hash marks are going to be a lot even, okay? So do keep that in mind, okay? But these are perpendicular, and the answer for things to be perpendicular is the fact that we want these slopes to be what's called opposite reciprocals, okay? So in order for the lines to be perpendicular, our slopes have to be opposite reciprocals. So what does that mean, okay? It means that your first slope is the opposite sign of your second slope. So notice 3 and negative 1/3 obviously have different signs. And then it's reciprocal, right? Which means that it's flipped upside down, right? So 3, if I flip it upside down, will be 1/3, right? That's a reciprocal, okay? Now, for some of you guys, an easier way for you guys to figure out if they're opposite reciprocals is if you do m1 times m2 is equal to -1. So that's saying if I multiply my two slopes together, the slope of my first line and multiply with the slope of my second line, I will get -1. Okay? Okay? There is an exception. So there is an exception with that, and that is if you have a horizontal and vertical line, okay? So these two lines are obviously going to be perpendicular, right? Because if I draw a a horizontal line, and then a vertical line, right, they'll cross at 90 degrees. Okay? And we know a slope of a vertical line, right, is undefined. And the slope of a horizontal line is 0, right? So 0 times undefined obviously is a -1. So that is our one exception, okay? But everything else, if you multiply our two slopes, it will be -1. Okay. Okay. So let's talk about the following, okay? Your problems essentially in 2.4 comes in two main components. So the first component is just determining whether your two lines are parallel or perpendicular or neither. And then the second half is essentially constructing lines so that they are parallel or perpendicular. Okay? So let's look at an easy one like number 1 here. Number 1, let's look at the following, okay? We notice that this one's definitely perpendicular, okay? So, because if I do 2 times -1/2, I get -1. So therefore, number 1 here is perpendicular. Okay? One thing, okay, that should be pretty straightforward is if you get either parallel or perpendicular, you don't need to check for the other. because it's no way possible, right, that being parallel and perpendicular can exist at the same time. Okay. Okay. So yeah, it's always one of those three options. Okay, now let's take a look at, for example, number let's do, for example, number 6, okay? So, if you notice, your lines are not in slope-intercept form, okay? Right, I actually don't know slope for number 6 because y is not by itself. So what I need to do is move my x over and then divide by 10. So I'm going to subtract a 5x, okay? And I'll divide everything by 10. Okay, so that is my first line. And then I'll do the second one. So I'll subtract 4x. And I'll add 8 on both sides. So I have 8y is equal to negative 4x plus 8. And I'll divide both sides, all the sides, by 8. So I have y is equal to negative 1/2 x plus 1. Okay, so let's talk about this one, because this one's kind of a one that people kind of overlook. Okay, so we notice that they have the same slope, right? So most people are like, oh, it's parallel. But the thing is, we have to realize is our y-intercepts are not the same. Sorry, are the same. So we're actually graphing the same line twice. So because of that, it's not parallel. It's definitely not going to be perpendicular, because if I multiply them, it's not going to be negative 1. So my answer will be neither. Okay? For the following right here. Okay. Right, and I can double check if I do m1 times m2, right? If I do m1 times m2, right, I have negative 1/2 times negative 1/2, that's 1/4, right? So that's 1/4, which is not the same as negative 1, so it's not perpendicular and it's not parallel, so therefore we say neither, okay? So there's going to be a lot of problems like problem 6. So the idea is you will have linear equations that's not in slope-intercept form. So what you're going to do is get y by itself. Remember from last video, when you are doing things in slope-intercept form, you must reduce your slope, right? So negative 5/10 must go to negative 1/2, negative 4/8 must go to negative 1/2. Otherwise, you're going to confuse yourself and you may think that your slopes are different. Okay, so okay, so let's move on right here. Okay. So it says write an equation of a line that contains 2, 9 and is parallel to y is equal to negative 5x plus 3. Okay, so let's talk about this right here. Since we know it is parallel, right, that means my first slope must equal to my second slope. So that means the slope I'm going to use, okay, I call m2 my new slope, must be negative 5 because it is parallel, right? It's parallel to negative 5x plus 3. Okay. Try to reconstruct the equation of the line. So we are going to do, here's the thing, what we're going to do next is essentially what we've been doing in section 2.3, right? Which is point slope form, right? So I know my slope, right, which is negative 5. And I know my coordinate, which is 2, 9. So I'm actually just using the y minus y1 equals m times the quantity x minus x1. So I'm going to do y minus 9 is equal to negative 5 times the quantity x minus 2, which would be y minus 9 equals negative 5x plus 10. And then I'll add 9 to both sides. And I'll get y is equal to negative 5x plus 19, okay? Let's talk about this. This should be parallel because they have the same slope, but they have a different y-intercepts, okay? Here's the thing too. When you're doing math problems, right, it's generally easy to mess up. But the idea is you want to kind of look and be like, does my answer make sense, right? So even say hypothetically we screwed up somewhere, at least I'm like looking at this, I'm like, okay, my answer does make sense because I have the same slope, I have a different y-intercept, and that is a definition of being parallel, right? If I got an equation here and my answer is like negative 3x plus 2, then you were just like, okay, that's definitely incorrect because they have different slopes. So again, one of the key skills in mathematics is you just want to kind of like take a step back when you do a problem and see if your answer makes sense in the confines of your problem, okay? And that's a very helpful skill rather than you just kind of guessing and be like, I'm hoping that this is correct, okay? Now, let's look at another example for parallel lines, okay? So this time right here, it says write an equation in a line that contains 4, 3 and is parallel to 2x plus y equals 12, okay? So once again, if your line is not in slope-intercept form, you must change it so it becomes in slope-intercept form. So here, remember, in order to get a slope-intercept form, get y by itself. So I'm going to subtract 2x. Both sides, I have y is equal to negative 2x plus 12. I clearly see that my first slope is negative 2. Since it is parallel, my new slope, or m2, is negative 2. So this is the one I'm using. Okay? And this is helpful. I know my coordinate, and I know my slope. So I'm going to do y minus y1 equals m times the quantity x minus x1. So I'm going to do y minus 3 is equal to negative 2 times the quantity x minus 4. And distribute. Everything we've been doing, everything I'm doing right now, we know how to do. And I'll add 3 on both sides. That's it. Okay? And so once you get to the hang of things, this shouldn't be actually very difficult, okay? Just make sure, if you're struggling with this, right, practice 2.3, that's what helps you, right? So if you notice right here, again, like this second half of this problem, right? Whoops, sorry about that. The second half of our problem, we know how to do, okay? We know how to do this problem because that is from 2.3. This is point slope form, okay, for the following. Okay, so let me show you. Let's go over next page. And again, some of the problems we don't do, practice those yourselves, okay? So that you can kind of get better at this, okay? And feel free to message me over some of the problems we did, okay? So it says write an equation of a line that contains 5, negative 6 and is perpendicular to the line y equals 4x minus 26. So let's look at this here. Now this time they want us perpendicular, not parallel, right? Perpendicular means, right, it is opposite reciprocal. Okay, so my slope is 4. My new slope, remember, so it's opposite reciprocal, so opposite sign, so it'll be negative. Since my original is plus, it'll be negative. Since this is 4 over 1, I'm going to flip it over, and this is negative 1/4. Okay, for the following right here. So this is the new slope I do, and then this is going to be a coordinate I'm going to use, okay? And once again, I'm doing point slope form. Y minus y1 equals m times x minus x1, okay? Now, one of the things you'll just kind of realize really quickly is that you will get, so again, this is just kind of an unfortunate thing with math, you will get things that will not have whole numbers. You will get a lot of fractions, and that's possible, okay? But it happens, okay? So make sure you practice distributing and adding fractions, okay? So notice when I distribute, right, this is definitely not going to be very clean, right? It's not going to be a whole number. Negative 1/4 times negative 5, okay? Remember, you multiply cross. 1 times 5 is 5. 4 times 1 is 4. So this is plus 5/4. Okay. I'm going to continue on. I'm going to subtract 6 on both sides. And I'm going to multiply, so remember, in order to combine them, I'm going to multiply top and bottom by 4/4. Okay. And this is going to be equal to, sorry, I'm going to move this over. Y is equal to negative 1/4 x minus 19/4. Okay. Okay, this can happen. You may have a y-intercept that's a fraction, okay? But this is actually good practice. So make sure you know how to add, subtract, multiply, divide fractions. Okay, that's essential skill for a lot of things we're going to be doing in this semester. Okay. Now, before we do another example, okay, I want you guys to kind of understand how your slopes that are parallel and perpendicular to the given line works, right? So parallel is pretty easy, right? It's just exactly the same. Okay. And then perpendicular, remember, is you flip your fraction. Okay. Remember, if it's a whole number, remember all whole numbers are over 1, but you'll flip your fraction and you'll do the opposite sign. We actually just did 4. It's perpendicular will be negative 1/4. Here, so I have 1/2. So 1/2 flips. It'll become 2/1, and it'll become negative. Negative 2/3 will flip, and it'll become positive 3/2. 4/5 will flip and it'll become negative 5/4. Okay, now the one here that you can't really do to m1 times m2 is m equals 0 because it's a horizontal line. So my perpendicular line is vertical and that's undefined. Okay, this is always the one that always trips people up. So be really careful with that one right there. Okay, that's the one you just have to kind of remember. But everything else, remember, you just flip and then take the opposite signs for perpendicular. Okay. So let's do see. Okay, yeah, let's do something like number 3, okay? So once again, you will run into problems where they do not give it to you in slope-intercept. So make sure you get y by itself. This is going to be a common theme that you'll see, right? So remember, you have a linear equation, sine slope-intercept, put in slope-intercept, which means you need to get y by itself. Right. So I moved a 2x over. I'm going to divide everything by 3. So I have y is equal to negative 2/3 x plus 4. What I'm going to do next is I'm gonna do the following. My first slope is negative 2/3. And then my second slope, let's talk about this. So since I want it to be perpendicular, I'm going to do the following. I'm going to flip my sign, so it'll be positive, and then 2 over 3 will flip over to 3 over 2. Okay. So once you know your slope, right, and then you know your point, it's the same thing we've been doing the past for 2.3, right? So you know your slope, which is 3/2. You know your point, which is negative 2/5. Y minus y1 equals m times the quantity x minus x1. So y minus 5 is equal to 3/2 times x minus negative 2. Okay, be really careful with your signs for that one. So you have a double negative. Three halves times x is 3/2 x. 3/2 times 2 is going to be plus 3. And y minus 5, if I add 5 on both sides, and then I get the following, y equals 3/2 x plus 8. Okay? Again, take a look at your answer, see if it makes sense. Okay, you're like, it does make sense, right? Because my slope is opposite reciprocal. Okay, and ideally we should hopefully get the math correct. Okay, but always look at your answer and be like, okay, does this make sense with what I have here? Yes, they're opposite reciprocals. So that kind of makes sense with my answer. Okay, so that is pretty much it for 2.4. I think this should be sufficient enough for you guys, but if you have questions, feel free to send me an email or kind of post on the discussion board. Okay, we'll come back and we're going to start with 2.5.